Good afternoon, everyone. My name is Professor Khalil Khalaf, and I will be your instructor for this semester, summer 2021, for the course Intro to C MCS 1142. So let me give you a little background about me. So this is my name. I graduated from Lawrence Technological University in 2017 with Masters of Science in Intelligent Systems. I currently work as a full-time development software engineer at a company called Perceptron Inc. in Plymouth, and a part-time associate professor at LTU. I've been working with the Perceptron for 4 years now and teaching at Lawrence for 4 years as well. This is my 4th semester teaching Intro to C. The last time I taught Intro to C was in 2019, and it was on campus. So this is the first time I do it through Canvas or online, and it's going to be asynchronous, as you probably already know. So I'll be recording the videos and then posting them at specific times. For the past 2-3 years, I've been teaching computer science 2 at Lawrence as well. So with that being said, I would love to hear a little background about you as well. So I'll open a discussion on Canvas. Please go ahead and submit the post talking about yourself and if you work or have worked in any tech jobs and the degree you are pursuing, whether it is at LTU or in a different university. So next would be, since it's our first session, I'm not gonna load you with a lot of stuff. We're just gonna go over basic setup, just so you guys get familiar or make sure that you are ready to go. So the first thing I would like to do is going through Canvas. Our Canvas, you probably already familiar with this. So let me show you the discussions that I opened. First of all, this is how you're gonna see it. These are the sections that we're gonna work with. So you have your home tab, syllabus, files, discussions, assignments, grades, people, Zoom, media gallery, your media. For the discussion to get to know your peers, you should see it soon. I will publish it, and you just go into that discussion and reply to that topic, and just type 3 lines is more than enough, really. Just so you know other students and other students know you. What's expected from you in on Canvas? So you should check new posted discussions at least once a day. So daily, go to the discussions, and if we have a topic for the week, check all the replies from other students, reply to other students. So just participate, right? And it's worth mentioning that participation is graded. The weekly discussions that we gonna try to implement in this course, they aren't necessarily related to the topics from the book directly, but would revolve around them in a way that should stretch your mind for the computer science field. So it would be like cool ideas about programming or computer science, interesting topics, fun puzzles, problem solving, stuff like that. Also keep up with all the uploaded files and presentations. So this tab is going to be our storage tab. Here you're going to have all the files as like Word document files for all the homeworks. If tests are through files, you're going to have the file right there. You're going to see all the presentations, the PowerPoint presentations. What else? Projects. We're going to have some projects, 4 projects across the semester. So that would be like one project every 2 to 3 weeks. you should be familiar, or it's expected from you to know how to submit the homeworks and do the test through Canvas. All assignments should be under this tab. You're gonna see homeworks, homework 1, 2, 3, 4, etc., and projects, and tests and quizzes. All of them are gonna be under assignments, and of course grouped by topic, so grouped by whether it's a homework or a project or a test or a quiz. Your grades section, the people, basically your peers, any Zoom meetings that we have. Now, the way we're gonna do this through asynchronous, I mean, it's gonna be recorded and then I'm gonna publish it. I'm gonna upload it on YouTube. I'm not gonna publish it, so it's gonna stay private. And whoever has the link can access the video. So I will record the video, I will upload it to YouTube, and then I will send you all the link. Then you can click on the link, watch the video, and you feel free to comment under the video whether you want, you have a question, something that you didn't understand properly, or you have a feedback, something I'm doing wrong or something is going wrong. Feel free to comment under the video or just private send me an email. And that would be it, basically. It should be straightforward and easy. We're gonna have 2 videos every week, and both videos will be shared with you at 5:45 p.m. On Tuesday and Thursday. I'm expecting from you to ask a lot of questions, and asking questions should help you get the most out of me. By me sharing my knowledge or explaining topics for you. The next thing I want to do is going over the syllabus. So I have it open here, or maybe not. I'm going to open it now. So this is our syllabus for this semester. Lawrence Technological University, Introduction to C. And this is my section, basically, my name, my email, and the semester or the course time periods, when, class location, office hours by appointment. So whenever you need help, just shoot me an email, and then we're gonna set up a meeting, a Zoom meeting, or we can just resolve it via email. You can contact me by email, and whenever you contact me, you should allow 48 hours for a reply throughout the week. This is the course title, of course, and this is the book. You should have the book. It's gonna help you go over many codes and practices, especially when it comes to tests. A lot of exercises are in the test. So the book is our reference. What I used to do as a student, I used to like find the cheap books online, and instead of getting the hard copy, I just get the electronic copy, the soft copy. Some courses I couldn't find cheap ones, so I just got the edition that was like before the required edition. Most of the stuff are gonna be similar, but of course you better get the one we are all working on. It's up to date, it has more stuff in it, you know, so pages are in sync. So so yeah, you're probably familiar with all these setups for each course. Any dates, important dates that you need to know, when to drop or when to withdraw, you should go to this link. Again, this is a textbook, and I attached the link to this book, or you can find it at the bookstore. You can go over these by yourself. So what is introduction to C? What's intro to C? What are the topics that we're gonna cover? Arrays, functions, file operations, and simple pointer types. I'm not gonna read this for you, and it's worth mentioning that the course overall, the majority overall of this course is gonna be me sharing Visual Studio and typing code, running the code, seeing the program, changing the codes, and running the program again. So I'm not gonna be presenting the PowerPoints for you or reading for you for several reasons, and I will elaborate on that in a second. It's also worth mentioning that it's very easy to take A's in this class, and I will also elaborate on that in a second. So these are the objectives that you guys will learn in this course. So by the end of this course, you will be able to explain or demonstrate all these objectives. So you're gonna know what's a variable and what are the different types of variables. You're gonna know how to document and how to comment your code. What is an if statement? What are switch statements? What are loops and what are the different loops? Functions, pointers, variable scoping, order of operations, and precedence. How to pass by value, how to pass by reference, and how to pass by pointer. You're gonna learn about arrays. You're gonna learn about screen input and output, so how to display to the screen and how to read from the screen. And at the same time, file input and output, how to read from a file and how to write to a file. These are the chapters in the book that we're gonna cover. So the book has much more than these, but this is our concentration for this course. So it's gonna be 1 to 7, and then 9, and then 11. Here we have the schedule. The schedule is demonstrating the pace of this chapter. So what are we going to do and when? So this is today. Today we're just gonna go over the chapters really quick and our syllabus. Next session we're gonna go over Visual Studio, how to set up your local machine, your computer, and how to run Visual Studio, how to open new project, how to start new program, how to execute, how to debug, etc. Then we're gonna have next week, so week 2, we're gonna have 2 sessions, week 3, week 4, etc. So chapter 1, 2, 3, then we're gonna have a test. 4, 5, 5 continued because 5 is a little big. We're gonna have a midterm for all the above. Then we're gonna have a review and feedback from the midterm. Then we continue 6, 7, test, 9, 11, and final exam. Final exam is everything above. And notice we're gonna have eventually homework. So starting next week, you get assigned a homework and then it's due, project, etc. I have to fix these because each homework is gonna be 1 week due. So this is gonna be posted week 2 and it's due next week. So I will fix these later and post them again. Let's move on with the grading scale. The grading scale, this is how you get an A or D. And it's worth mentioning that it's very easy to take A's in this course. What do you have to do or how you have to do it? You need, I recommend that you read each of the chapters before attending the meeting. For example, you know that at this date we're gonna speak about chapter 4. You better go and read chapter 4 before watching the video or before attending the meeting. Also go over the PowerPoint presentations and practice the code posted in them. So in each PowerPoint presentation that I'm gonna post on um, our files. So in each PowerPoint presentation that I will post regarding that session, it's gonna have code picked from the book and reflects the most out of that chapter. You might see that same code in your homework or in your project or in the test. So I recommend that you go over those and practice them by yourself on your laptop. Of course, send me any questions you have or any issues you're facing. We can go over it and resolve it. So yeah, do that. Go over the posted presentations and practice the code posted in them. Also, if you want to score the A really easy, do the homeworks by yourself. If you do the homework by yourself, and you can, of course, ask me as a professor, but I'm saying don't get any help from anybody else. If you do the assignments by yourself, you can guarantee getting an A. Ask me as your instructor or refer to the book for your source of information. Also, assignments and tests are very easy, but only when you first do your part. And it's worth mentioning that things get confusing really quick. So you better keep up um, with the topics, which is demonstrated in the syllabus. So what I'm trying to say is you have chapter 1, chapter 2, chapter 3. Things are built on top of each other. So you start with chapter 2, chapter 3, chapter 1, 2, 3. 3 is built on 2. 4 is built on 3. 5 is built on 4. So you need all the above in order to grasp the most out of that chapter. If you miss one, you're gonna have a hard time understanding the current one. So make sure you stay on top of the topics. What else do you need in order to score an A? That's basically it. Do the homeworks, read the chapters, and never miss a session. And this is how you get an A regarding the mapping for the grades. So which grade gets you with which letter. And this is the broken down grading for reaching 100. So we have 10 homeworks, which is one for each. And this is the policy. Any homework that you miss, it's going to be scored as 0. Any homework that you submit that is incomplete, it's going to be scored as 0. So if you submit a homework that is not running, for example, your program doesn't run, it's scored as 0. Your program has to run. It has to be free of syntax errors or logical errors. And we're going to elaborate on what's the difference between syntax errors or logical errors. Class participation, this is basically your discussions, questions, anything related to the videos, attending the class participation. So we have 3. Class attendance, we're gonna see how we can work out these 4 points since it's online and asynchronous. So we will figure out a way on how to score attendance for each student. We're going to have 4 projects, 2 points for each. Same case for the homeworks. 0 will be scored for incomplete or missing project. They are similar to homeworks, but every project combine 2 to 3 homeworks at the same time. And eventually it's a longer period. So homeworks are 1 week due. Projects are 2 weeks due. Test 1, we're going to have test 1 in 3 weeks. Then we're going to have a midterm in another 3 weeks. Then we're going to have test 2 final. So 3 weeks, test one, another 3 weeks, midterm, then other 3 weeks, test two, and finally, final exam. And this reading, you can go over it by yourself. Of course, plagiarism is not allowed. Policies, or our policies are here. Um, uh, like pretty much like any other course. Late work, the policies for late work, technology tools, how and what to do if you need help, and which platform are we using. Eventually, it's Canvas, and that's pretty much it for the syllabus, really. Are we missing anything? No, that's it. That's it. So next, I would go over the chapters really quick that you are responsible of. Some students like to read the book, like the entire book before the semester, or at the very few first weeks of the semester. So it's good to go over the chapters uh, in a skim way. We don't go into details as much. So chapter one, what's chapter one? I have the book in front of me, which is how to program, and 8th edition. So the first chapter is just an intro to computers and the internet, how everything is connected and related to each other. So what's a hardware, what's a software, what's some laws that we know in computer science, some guidelines, some rules. Um, and the data hierarchy, what's the biggest unit to store, what's the smallest storage unit, difference between languages. So you have different type of languages, and for each, let's call it type of language, you have different programming language. Just like you have as a humans, we have like Chinese language, English, Indian, etc. We have different levels of languages. So you have a machine level, you have an assembly level, and you have a high level. So what they mean by, the way I remembered it was pretty much if you do an arrow, so like this, so high level and low level. What they mean by high and low level is human is on top. So let's draw, let me demonstrate my amazing painting skills. So this is a human, right? And on bottom, this is a machine. So I'm trying to draw a computer, which is pretty screwed, like this. So high level language means it's close to the human, means it has some English into it. So the human has an alphabet, A, B, C, D, E, F, G, etc. And the machine has ones and zeros. 1, 1, 1, 0, 0, 1, 0, 0, 0, 1, 1, etc. So a language that is low level means its alphabet is ones and zeros. A programming language that is high level means it has alphabetic English alphabet letters in it. So when you read the code, if it's a high level programming language, when you read the code, you're pretty much reading English. For example, an if statement or a loop or a switch. You're gonna read the code will say the word switch, and then there is like some specific syntax. So this would be a high level programming language. High level because it's close to the human being. Now, the closer to the human being it is, the programming language is, the harder for the computer to understand it eventually, because there's all those translators in order to reach the 1 to 0. Like this switch is going to be translated to some middle language, and then this middle language will be translated to ones and zeros. So the higher the language is, the slower it is on the machine, and the lower the language is, the faster it is on the machine. The lower it is, the more confusing it is to humans. It's very hard to read a code that just says 101010. It's pretty hard for a human being, but it's very easy to read alphabets. So this is the difference between low-level programming language and high-level programming. And we're gonna go over it in once we reach that week, which is next week. Then you're gonna learn about in chapter 1. The next topic would be the language intro to C itself, where it is in this diagram, and different programming languages, like we have C++, we have C sharp, you have C, and you have other stuff like JavaScript, you have Python, you have pretty much a lot of programming languages. And we're gonna see next other than intro to C, you're gonna see other like a brief about other programming languages. You're gonna learn what is an object, what is meant by an object, what is meant by messages and method calls, what is meant by variables, parameters, encapsulation, inheritance, and those are just a brief. You're not responsible to know every piece of information in details, and you're not going to be tested on those. This is just an intro chapter. What we will see also in that chapter is how to create a program, basic program, and we're gonna basically do it here. So we're gonna go over it in week 1, and you should be familiar with it. Like, boom, in 2 minutes you can create a program, simple program, of course. How to pre-process a program and how to compile your program, how linking works and how execution works, and the problems that may occur or you might face in execution, like different errors. What are the different errors that you might get? You have a syntax error, logical error, runtime error, etc. Then pretty much it. So this would be in chapter 1, operating systems, the different operating systems we have, how the internet works worldwide, and these are just a brief topic. Then we're gonna jump to chapter 2. I'll have to fix those. Yeah. Then we're gonna jump to chapter 2, which is the language we're gonna use intro to C, which is the C, but in details. So what is this language? And we're gonna start typing some codes to print to the screen or to read from the screen. Some arithmetics, like adding 2 numbers and displaying the results. So for example, you write a program that asks the user for 2 numbers, and then it displays the result of their sum or the result of their multiplication. And that would be a very simple program, good as a start. And we're gonna go over memory concepts, so how things are stored in memory. We're gonna go over arithmetics, how arithmetics works, like addition, multiplication, subtraction, etc. Then we're gonna go over decision making. So for example, you're gonna write a program that asks the user for a number, and then it for example, asks the user for 2 numbers, and then it will display if the first is greater than the next number, or the first is less than the second number, or they are equal. So in your code, you're going to do some decisions on whether these 2 numbers are equal, or one is greater than the other, or one is less than the other. And how to do a little secure programming, how to keep your code modular and contained, not random. in a way that is randomly organized, like your lines are not in proper order, because they have to be in proper order for better reading, for better debugging if you have any issues. So you don't, so you always want your code to be organized. And there are a lot of standards that, for example, Google wouldn't have been Google if they didn't follow an organized, ordered standard of writing code, because again it gets really confusing really quick when you have like many lines of codes. Imagine you have a document that has 1000 lines of code, and then there is a problem or an issue or an error in that line of code. You would prefer that uh, that file to be well organized and following some standard. So we're gonna elaborate on that. Then we're gonna jump to chapter 3. Chapter 3 is going to be about structure, how to structure your code. So not just following a standard, not just following an order, but structured. So you have this section responsible for a specific task, then you have another section specific for another task. You're going to learn about algorithms and how to communicate your code. So if I type a code, right, if I go back to this, imagine I am writing in a language that is middle. So let's say assembly language. Assembly language has like commands like add, store. So just command add and then number. Stores and then a number. This number could be uh, a memory, like memory address inside the machine, or an actual literal number. So 1234 means 1234. Um, so imagine I'm doing this and I want to communicate my program or how my algorithm work or how my procedure work to someone who's untechnical, or not necessarily untechnical, might be technical, but who doesn't know this language. So I need to communicate. How do I communicate my algorithm? There are many methods to follow. There is something called pseudocode or something called flow chart. So you have like a diagram that says, oh, at this point I do this, and then I do a decision making, either go like this or like this. So I draw a diagram and then I communicate that diagram to the other peers, and then they're gonna know how the code works. That would be like the design of the code, and this would be the implementation of that design. So you're gonna learn about these, how your control flows inside your code. So like you start at statement, a code, then it jumps to the next statement. So you have a control flow. So the control will flow like that, and then you have a decision making. You either do this statement or this statement. So your control is gonna go to this statement or gonna jump to this statement. So you're gonna learn how how that is actually working under the hood. For right now, at this very specific moment, I'm gonna stop recording, stop sharing, just to make sure that the video is record. Well, never mind. I will just keep going. If anything is wrong at the end, I can always restart. So back to the syllabus. So chapter 3. In chapter 3, yeah, chapter 3, you're gonna learn control. You're going to learn about the if statement, the if else statement. You're going to start seeing loops, which is the first type of loop, the easiest type. It's called while loop. So so in your code, you want a statement or a piece of code that keeps running, maybe infinity, maybe for a specific period of time, or maybe for a specific value. For example, 10 times or 15 times or 30 minutes or infinity. Like you see this blinking, this is under a loop that is running infinity. It will infinitely blink. This whole software is running under a loop, right? It's always running, waiting for my input. So you're gonna learn that some programs require a specific value, like loops under specific value. For example, I only want to take 10 numbers from the user. So that loop is going to repeat itself 10 times only. And you're going to learn how to implement that. Uh, mm, and let's see. I'm looking at the chapter really quick. Um, gonna learn what a sentinel is. Sentinel means keep running this loop until something happens. So it's not really specific, but it's not really infinite. So it's gonna keep running until one event happens. For example, this is running until I click close. When I click close, then stop running. So that's called sentinel. Or sentinel can be also uh, demonstrated as you have like you have a container that has 100 slots, but there is only 20 items in it. So how do your code know that it's only 20 items and not the entire 100? You add a sentinel at the end, so the code will keep running until it hits that 21st slot, which has a sentinel in it. Then it's gonna learn that, oh, okay, I'm done. There is no more items because it hit a sentinel. A sentinel can be anything. So let's say you have a container of numbers, right? Let's say this is my container. So I have first item is 1, second item is 4, then 6. Let's say it's grades or number of apples for each student, and I only have 20 students. So I have 100 slots in my program, but only 20 students are filled in that slot. So I'm gonna have numbers in those first 20 slots. But then when I reach the 21st slot, I have a sentinel as negative 999. So logically, there's no way that a student has a negative 999 apples. So my program can use this value as a sentinel. So it's gonna start learning, hey, are you negative 999? No. Okay, then there's more. Are you negative 999? No. Okay, there is more. Until it reaches negative 999. The program will know, oh, I reached negative 999. That means there is no more data. So terminate. So this is Sentinel, and we're gonna see it working in week two, sorry. Then you're gonna see nested, something called nested. Nested means a statement inside a statement. For example, if you have a loop, imagine you have a loop inside a loop. Or if you have an if statement, you have an if inside an if. Like if I have a car, then inside that, if I have gas, then inside that, if I have a map, or a direction or a green light. So stuff like that nested. Then you're gonna see assignment operators. So how to assign values to variables, how to reassign values to variables. So one time this variable has a value of 5, the next time, the next iteration of the loop, or the next when the user gives us a value, I reassign a new value to that variable. You're gonna see increment and decrement operators. So how you have a variable with value 10, then you increment it. Now it's 11. You increment or decrement, and it is very useful. You're gonna see how you're gonna be surprised how much you use incrementing and decrementing in coding. Then we jump to test. We're gonna do a simple, small, easy test for all these 3 chapters. Then we go to chapter 4. Chapter 4 is gonna be mainly about uh, how like to manage your code, or how to control your code. And then you're gonna see some syntax. You're gonna learn some syntax like counter controlled, um, for loops, do while loops. You're gonna see switch statements. You're gonna learn about break and continue statements. You're gonna learn about logical operators. Logical operators are like and, or, not or, and XOR. So you're gonna learn about those, but basically, and goes inside an if statement. So remember how I did this example about if I have car inside it, if I have gas inside the, so you can have all these conditions in one statement. You can say if I have a car and I have gas, then do a task. So with and operator, when do we invalidate that condition? If one of those two conditions is false, then the entire statement is false. So I'm saying, so your statement goes like this: if you have car and you have gas, so what if I have car but I don't have gas? Then the entire statement will invalidate. It will it will return false. So it will not execute because one of them is false. On the other hand, with the or operator, let's say if I have a car or I have a bicycle, then do a task. So if one of them is false, if I don't have a bicycle, I can still do the task because I have a car, because the statement says if you have a car or you have a bicycle. So if one of them is true, any one of them is true, then the entire statement is true. So this is something that you're gonna see in chapter 4. And um, that's it for chapter 4. Then we go to chapter 5. Chapter 5 is pretty cool and very I would say important, very critical in computer science, because you're gonna see it everywhere. If you don't do it, you're a bad programmer, considered bad programmer, and you can't really be in this field without doing it. It's called functions. Functions means grouping, grouping piece of code or grouping number of statements under a function, and then you call that function for several reasons. For not duplicating your code. So if you want to do the same task over and over and over, you put it in a function, and then you just call that function. Instead of typing the same line of codes everywhere, you just write it in one place and then you call it everywhere. Uh, Also for code readability, instead of having everything dumped in one place, you have them in separate places. For example, this file is responsible for the colors on the screen. This file is responsible for moving the car forward, backward, left, right. This file is is sorry, responsible for monitoring the engine and stuff like that. So it will help you being organized. So chapter 5 is gonna say what's a method, what's it's called method as well. So method or a function. So what is a function? What are the functions that you can use that are provided to you? So when you create a program, you don't reinvent the wheel. You don't you don't create everything from scratch. There are stuff that are provided for you. You just use them. You use built-in stuff to build your program, and those are existing functions. How to write a function. If you want to write your own function, how to write your own function, and the naming, the labeling, like this is called function definition. This is called function body. This is called parameter. This is the return type, etc. And we're gonna see some examples. Of course, most of our sessions again are gonna be Visual Studio. It's not gonna be reading. Like right now, I'm right now you see text and I'm reading, but it's not gonna be this case for several reasons. One of the reasons is uh, coding. Coding is like bicycle learning how to ride a bicycle or learning how to play a guitar. So with coding, with programming, you can spend 5 years reading about it. You're not gonna know how to program unless you do it, unless you practice it. You have to use your fingers and run the program, compile the program, debug steps through the program. This is how you learn programming. You don't learn just by reading it. You have to practice it. It's all based about experience with your working area, with your uh, platform, whether it's Visual Studio or any other compiler or IDE. So you're gonna learn also about what is meant by function prototype, what's the call stack, and what's the stack frames, like function calling another function, calling another function. So there is a stack of calls called call stack. You're gonna learn about headers. You're gonna learn how to call a function and send some values to it and return some results from it. So you're gonna have a function. You're gonna say, "Hey, function, here is two numbers. Give me the multiplication of these two numbers." You're gonna learn how to pass by value or pass by reference. So you either pass the value as copy of it or you pass it as is. You're gonna see that more in details. We're gonna learn about the random number generation function, a function that generates a random number. And you're gonna be also surprised how many times we use random number generators, because random number generators are pretty much everywhere. Um, for example, if you play PUBG or Warzone, it has a lot of randomness, right? Like when you jump from the airplane, there are houses. Those houses are not randomly put across the map, but in each house there is a box that has a random weapon in it. So if you jump at the same house twice, you're not gonna see the same weapon. Why? Because when the match started, there was a random number generator that randomly picked weapons and randomly distributed them across the map. So it's very important to know if you want to do some games or even not just games. It's very good to know how to manage or create a random number. You know, I want a random number between 500 and 1000, or I want a random number just minus infinity plus infinity. Well, it's not basically infinity, but minus maximum, negative maximum to positive maximum, any random number and stuff like that. So it's good to know how to manage and create those. You're gonna learn again scoping rules and recursion. Recursion is pretty tough, but in this class you are learning the idea about recursion. You're not gonna be asked or tested to build a recursive function. Even computer science 2 students can't really build a sophisticated recursive function, even at the field. The recursive function we're gonna see it later. Then you have chapter C, which is arrays. Well, after that, we have midterm for all the above, also projects and homeworks along the way. These are gonna help you grasp all this, and it's gonna help you practice all this. Then we go to chapter 6. Chapter 6 speaks about arrays. Arrays are containers, like bucket of items. Like imagine you have one variable or you have an array, which is a number of variables. So array stores multiple values in it, and you can access each of that uh, item or each slot in that array. So you're gonna learn what's an array, uh, how do you create an array in your code, how do you iterate that array, how do I access the entire array from the beginning to the end in an iterative or a sequential or linear way. Um, and how to grab items from that array and do something with them, process them, whether you want to add them or subtract them. Um, the different arrays, you have a character, a number, etc. Or you have local arrays and you want to pass them to a function. How to storing arrays, how to store inside arrays, how to compute, like how to do a running total, like go over the array and sum the entire items together, or get their median or get their mean. So this chapter is defining arrays and working with arrays. Then the next chapter is C. C is a little challenging, but it's very easy when you understand chapter 6 and everything before it. Like if right now you go and read about chapter 7, it's gonna be a little confusing. But if you know all these, then it's gonna be very easy. It's very easy, similar to chapter 6, just different notation. So it's called pointers. pointers. So basically, instead of working with the function in a direct way or working with the variable in a direct way, you are just working with a pointer that points to that variable. Like imagine you have a mail in a mailbox and you have a key to that mailbox, and that mailbox has an address in it. So you are either going, let's say you want to give that package to your friend. You can either work with the package directly, meaning going to the mailbox, opening that mailbox, getting the package, and then giving it to your friend. Or you can tell your friend, hey, you see this key? It is the mailbox number X. Then your friend, so you're working with a pointer to that package or to that variable. So you give that pointer or you access that pointer to in order to retrieve the value inside that variable. So this is the idea of pointers. We're going to see it in detail and we're going to see it working. What is a pointer? How to pass a pointer to the function? The different types of pointers. You have a constant pointer to constant value, constant pointer to variable value. You have a variable pointer to constant value, etc. And how to do arithmetics with pointers, how to express pointers, how to access pointers, how to reassign values to the variables that the pointer is pointing to, um, adding two integer pointers, arithmetics basically. You can do arithmetics on the pointer and you can do arithmetics on the value that the pointer is pointing to. So that you can play with the address or play with the value itself. Comparing pointers, which pointer comes before the next one or which pointer is greater than the next one. How to have a container of pointers, like an array of pointers. And that's it. Then we go to chapter, so we have test 2 on 6 and 7, arrays and pointers. Then we go to chapter 9. Chapter 9 is pretty straightforward, and these are things that you kinda want to understand, but I think as a student I had to memorize them. Like maybe this is the only section in computer science that you and programming that you have to memorize it. There is no way that like you don't memorize it. So it's called C formatted input and output. So how to format your output. Let's say you see how these formatted, you have a column and then you have this space and then you have a letter and then you have this space and then you have this letter, then you have, so it's formatted. Like for example, if I type here, I can say my name tab Khalil, you know, like for example, sorry, this is a better example. Name, right? School, city, etc. City, phone number. So then I go enter, name is, this is my name, LTU, Southfield, etc. So you see how it's formatted, name, tab, school, tab. So sometimes when you, most of the times, or maybe most programs that you've seen, when they display anything on the screen, they are formatted, they are organized. So there are some operators that you use in order to display a tab, for example, or display a space, or display exactly 10 spaces, or numbers, for example. Let's say I have the number pi 3.14, I think 14.5. Let's say it's 14.5. Then I can format it. I can tell the program, okay, display 10 digits after the point, or only display 2 digits after the point. So you, there are some operators that you can control these. Or I want to display, for example, like our IDs. I want to always display 3 zeros before the number. So my ID is, I don't know, 722 something. So our IDs always have 3 zeros. So stuff, this is chapter 9. It's operators on how to do different things on the screen. So the value is the same, but you represent it on the screen in a formatted way. So formatting, mostly formatting, literal and escape sequences. Then we go to chapter 11. Chapter 11 is, what is chapter 11 again? C file processing. Okay, so chapter 11 is how to write to a file and read it from a file. So consider it as a database, right? Database is something that you store data in it. So a file, you can store data in the file. So this way, before, for example, your program shuts down, you save the state or you save the value or you save the variables inside that file. Then when your program runs again, you can read from that file and then you're back to that same state. So when you close, you save. When you open, you load. And we're gonna learn how to write and read from a file, how to format a file. So everything above, really, everything above. How to read data from a file and then call functions, give them some variables, and then get the result and save the result in a different file or in the same file. So this was it. Hopefully you enjoyed this session. Hopefully you're gonna enjoy all this semester and get an A. I'll be more than happy to help you get an A. Good luck and nice to meet you all. I'm gonna be excited to hear your background on the discussion section. Take care.